All right, so with this one, guys, we need to make sure that we're all on the same page. And what I mean by same page, it's just that we have all the same notation, all the same expectations. So this very first, 5 minutes, you're going to go, I know this. And that's supposed to be the whole point, okay? You're supposed to know it. But let's make sure we're all there. Now, today what we're doing is we're going to apply the distance and midpoint formula. Why are we applying those? Because they deal with line segments. Haven't we been learning with line segments? So make sure that you know those. First of all, a coordinate plane. Does everyone see a pretty coordinate plane on this? Yeah, it's right there. Really, isn't that just two number lines perpendicular to each other? Yeah, and so that way we can locate where a point is, because what's a point? A point's just a location, right? So that's why we have coordinate planes. So let's write down what it is. A coordinate plane is a, get this, a plane divided into 4 equal regions. Now, those equal regions, we're going to stop here for a moment, are called quadrants, right? Quad means 4. All right, guys, where's quadrant 1? Top right, correct. So top right, so quadrant 1. And then you go counterclockwise. Think about if you're making a capital C, that's the direction you'd be going. That's if you make capital C's correctly. All right, so we have quad 2, quad 3. You don't think this is important, but guess what I'm asking my students all the time in pre-calculus right now? All right, what quadrant is this located in? So you're going to have to be able to refer to those real quickly. So it's just a good thing to always review. Guys, what do we call the horizontal number line? What is that one called? Yeah, that's going to be your x-axis. So that helps us with the coordinate. So here's our x-axis. All right, what do we call the vertical number line? The vertical line. Remember, vertical means up and down. That's going to be your y-axis. So here's your y-axis right here. And remember, we have positive and negatives where the location on the number lined. Now, remember, a point is a location. We're the one that gives it a dot. But we can now give locations based off of our coordinate plane. So guys, just plop this point down here for me. I had someone in one of my periods go, where did that come from? And my answer was, I drew it there. Okay, so, right, it's just there. Now, how do I tell where that location is?
Go on the x-axis.
She said, yeah, I go on the x-axis first from the origin, right? How far did I go, guys?
3.
Positive 3 units, right? And then what do I do, Thomas?
Just go up.
And I went positive 2 up. Doesn't that give me an ordered pair? Notice I don't put the PT in front of it because I have a parenthesis here. So that's going to be, point A is at 3, 2. That's the coordinate for point A, right? Now, if I want to say that it's a point, the parentheses automatically signal to me that's what it is. And remember the rule. You always name the X first, and then you name the what? Y. Here's a jokingly way of remembering that. You have to get to the elevator before you go up or down. Kind of make sense? All right, so it's an easy way of doing that. Now, just because we know this stuff, and you've learned it this chapter, if I put a line, say a point over here, I know that 2 points can determine a unique line, right? Any 2 points. Can that mean they also determine a line segment? A line segment has a beginning and an end. It's not a line, it's part of a line. There's a big difference. Lines don't have middles, but line segments do, right? And if I want to find a midpoint, and I'm just going to eyeball it, it looks about right there, doesn't it? I should get 2 congruent what? I should get 2 congruent segments. So I'm looking for that midpoint. But I don't want to have to sit there and draw it and try to calculate every single time. I want a fast, easy way. That's when we use the midpoint formula. So that's where we're going. Now let's see if we can do a review, because this is going to be on your test, plus it's what we're really doing. What is the definition of a midpoint? If you're wrong, it's okay. Just give it a shot, though. Give it a shot for me. All right, which one of the 3 guys should I pick here? Which one's the most confident? Look at each other in the eyes. Which one's the most confident?
Go, you got this.
You guys, oh, I'm getting the stare down here. This is intense. Okay. All right, which one? Pick. You're even being nice with the stare down. All right, Peter, go. All right, you guys were too nice.
It's a point in the middle of the line.
Okay, that's the general. If you told me that, I'd be know exactly. Keep going. It's a point on a line segment that does what? All right. It's a point on a line segment that divides or separates, right? You say it the same way, divides or separates the segment into two congruent segments. That's what Peter said. Does everyone understand? You all can locate it for me in a heartbeat in your head, can't you? But why do I want to know the two congruent segments part? Because isn't that what it's doing? Physically dividing it into two pieces that are exactly the same shape and the same size. So really, combine those two together. All right, combine them together. But I don't want to waste my time counting it to figure it out. I want to figure out how far it is horizontally, vertically. I just want to have a formula that does that. And that's when we use the midpoint formula. Notice here, those are called subscripts. Subscripts do not square or anything, okay? They just say that those are two physical coordinates. One that we're going to call point 1, one we're going to call point 2. So subscripts are going to be used. The formula is very simple. It is the average of the x's. Averages, do you add or subtract? Add. So it's x1 plus x2 over 2, comma. And it's the average of the y's. So I get y2 plus y1 over 2, comma. Now, what's enclosing that formula? You have to have it. Did everyone hear me on this? Because a midpoint's an ordered what? Pair. And if you don't have the parentheses, you're not telling me you have an ordered pair. So it's not the same thing. Yes, right.
Does it matter which y goes where? Or?
As long as the y's are together and the x's are together is really what matters. But I'll show you kind of a way to keep track of yourself with it. All right, so let's find the midpoint of line segment DE. So I want to find the midpoint of line segment DE. Guys, this is what I need for you to do on this homework. This formula we use all year long. You need to memorize it correctly. So every time you use it, guess what I want you to do on this homework? Write it down. Did everyone hear me on this? I say this every year, and half of the people seem to miss this. Every time you use it, you do what?
Write it down.
All right, so we're going to write this one down. So I got my x1 plus x2 over 2, and I have my y1 plus y2 over 2. Now, if you want to be fail-safe on this, you take your 2 points and you label them. You label them point 1 and point 2. It does not matter which one you call point 1 and point 2 because I'm adding, so it doesn't matter which one goes first or which one goes second. What matters are the x's go together, and what matters, the y's go together. So then all you have to do with your formula is go directly below it. So what's x1 plus x2? Well, x1 is 2, x2 is 4 all over 2, y1 is 5, y2 is 7 all over 2. Now please do this math in your head. Please listen to me. Don't give me decimals, give me what? Fraction. So if there's a fraction, just leave it as a fraction. It's going to be over 2, okay? So when you have that, you got 2 plus 4 is 6, divided by 2 should give you 3. 5 plus 7 is 12. All over 2 is going to give you 6. There's your midpoint. Was that hard? No. All right, so let's do it real quick. Actually, let's see if you can beat me done. Go. Showing your work completely, including your formula. And I'm going to take my time, so if you don't beat me, I'm concerned, guys. If I walked around, do you have work shown and formula shown? All right, how'd you guys do? Did we get it right?
Yes.
All right, notice, did I worry about changing that to a mixed number or a decimal even? Long as it's in simplest form, life is good. But ask yourself, did you put parentheses around it? Everyone have a parenthesis at the end?
Yep. Yeah.
Did everyone have a formula down?
Yep.
Okay. He can fix it. Okay, man, you are really cruel over here. Wow.
Wow.
Some people are a little competitive. I'm just telling you. Oh, no. Okay, here's the other thing, though. Drew, make sure if you have 0 divided by 2, it has to be 0 for your final answer. Okay? All right. Now, this is not, okay, that's too easy for you guys. You think I'm going to leave it easy? Come on.
Yes.
We're going to do a little bit different than that. I'm going to give you the midpoint, and you have to find the end point. Okay? It's not that bad. Okay, I call these work backwards problems because I'm still going to use the midpoint formula, and I already know the endpoint, but I'm going to work backwards to find one of the coordinates. So you're going to get tons of work backwards problems with me in here because we can always take our end with what we know. So here's the one thing we do know. I'm going to kind of give you a diagram here. We know x is over here at 2, 7. We know, notice this is so not drawn to scale. M is over here at like 6, 1, and I'm waiting for lonely y. I'm going to call x, y, but you can kind of get a gist of where it should be. Most of you probably are logical enough to go, I think I know it already. Okay, you know I want the algebra from this, okay. But you should have a good idea of what it should look like or where it should be located. So with this, I know this is true. I'm going to put the formula down. I know that x1 plus x2 over 2 plus y1 plus y2 over 2 equals my midpoint. Sorry, there should be an equal sign there. I know that's 6, 1. Right? I know that's my endpoint. I know I've got, not my endpoint, excuse me, my midpoint. And I know I have one of the ordered pairs. So can't I call this ordered pair right here, x1, y1? Isn't that what it is? It's one of my 2 points. And can't I call this one I'm going to, my x2, y2, x and y? Because then I can plug it into my formula. So then I got my x1 is 2 plus x all over 2. Then I get my y1, which is 7, plus y over 2 equals 6, 1. Now here's what we're going to do next. Now we're going to break it into parts, right? What do I know about this and this? What's so special about them? They're both x's. They're equal. So guess what I want you to do? Set them equal and solve. If they're equal to each other, I can solve for it. So when I have that, I got 2 plus x over 2 is equal to 6. Now this is where it's fun. Oh, I don't like it there. I'm going to move my location so I have a little more space. 2 plus x over 2 is equal to 6. Can I just solve? What do I multiply both sides by? 2. So I get 2 plus x is equal to 12. What's x going to equal?
10.
Was that hard? No. All right, now I want to solve for y. So am I going to use the kind of the same type of concept? Am I going to use, I don't think that highlighted like I wanted it to. Don't I want to use the fact that those two are equal to each other? So I'm going to do it that way. I'm going to sit there and go, okay, I know 7 plus y over 2 is going to be equal to 1. Now it's just fun algebra again. Multiply both sides by 2. What's y going to equal? Negative 5. Okay, what's your ordered pair for y? All right, everyone should be able to tell me this. It's going to be what? 10, negative 5. What do you guys think? If I know one of the endpoints in the midpoint, should I be able to work backwards and get the other one? All right, guess what we're going to do? One more of those. See if you can beat me done. Go. But show your work the right way. All right, I think I made my point enough. So you can see yourself the visual, give yourself a visual. If you don't need the visual, that's okay on this one. And we are looking for B, right? Not on this one, if you can see it, but I would say it's a good one to have. What'd you guys get? 6 what?
Negative 8.
Good job. 6, -8. Excellent. Most of you are almost there, right? Just give me an as, and notice how I use the capital B next to it. It's just labeling it, right? That's point B with it. If you just had the ordered pair of 6, -8, would I give you full credit?
Yes.
Yes. This is known to show up on finals before. What should you mark? Okay. And I've seen this on the actual ACT before. And if you're stuck, drawing it out could also help you get the answer, right? So if you're stuck, use the visual cues. All right, next one, distance, okay? Anytime you hear the word distance, that is the same thing as the length of a line segment. Because to have distance, don't you have to have a beginning and an end? So the length of a segment is really the distance between the points that would make it, its endpoints. So interchangeable words that you have to be able to know. Now, again, remember how some of you were like, oh, I don't remember this, I haven't seen it before, but once I reviewed it with you on your algebra assessment, you were like, this isn't that hard? This is one of those, this isn't that hard if you have the formula memorized. So let's write our formula down so you can have it memorized for the test next week block. So I have the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Do you see how you could easily confuse midpoint and distance formula just a little bit? Midpoint you average, so you add. Distance formula, there's adding, but you also have subtraction stuff in there. Now I'm looking for the distance. This is actually based off of the Pythagorean theorem. The idea that I have 2 points, notice there's subscripts again, x1 and x2, so I still will use the labeling the same way. Yes, sir?
Why do we need to have the square root and the squared sign?
Because they don't cancel out. Do you see this lovely little sign there, that plus sign? That has to be done first before I can take the square root. You can't break it into the 2 parts. Guys, when you have this, if I have the square root of, let's go 3 squared plus, and let's use 4 squared. That's something you guys know really well. Okay, we know that the proper way to do it is you simplify first, so you get 9 plus 16, you get the square root of 25. That gives you what? 5. Now, look at this. Square root of 3 squared plus the square root of 4 squared. What do you get? 3 plus... Is that the same thing? This one is illegal. There's a joke that we have hanging up in the math department that every time you do that wrong, you kill a puppy. Yeah, it's horrible. It's horrible. But it's a good way to remember not to do it. You know, it's like, oh, I don't want to harm poor harmless puppy. You know, because that is an operation sign that says the operation has to happen first before you can break it up. So remember, it's glued together. That square root sign is almost like a big parenthesis that you have to do first. Okay? So let's have fun. We're going to not do every example. We're going to do this first one, then we're going to skip the second one because it's doing the same thing. I think we can don't have to do every single one. But it says on this one, look what notation says. Find, what does that read?
Segment FG segment.
No, doesn't say segment. It reads this way.
Of one segment FG.
It reads the length of line segment FG and the length of segment JK. There's a difference. So make sure you know if you have an equal sign, there's no bar with it. This is equal. So when I do that, let's do FG first just because it's listed first. You have to have the ordered pairs. So G I know is over here at 5, 5. F is over here at 1, 2. Now, with that, do you agree with me? I'm going to have to label my 2 points as X1 and X2. Does it matter which one's which? No, I'm just going to do X2, Y2 for this one, and I'm going to do X1, Y1 here. You get to the point, you don't have to label the points. You get to that good. But right now, you have to write your formula down. Did everyone hear me again? There's always someone stubborn in here who says, I don't have to do what she says. And that's always the person who loses their points on their completion grade because they didn't write the formula down every single time. You guys aren't going to be that way, right? You're going to be my good students? Same thing with the test. I want to see the formula. So, with this one, yes, Peter?
Question, if I do y1 plus y2 over 2 plus 4, oh wait, no.
Don't do that. You always want x's first.
I know.
Okay, in midpoint, you always want x's first. Okay, good question. Now, could you write this formula x1 minus x2? Or y1 minus y2? Guess what? You could, because what am I doing to it? square root. So you gotta be really careful, but you have to always be consistent the same way. So it's best to memorize this way. This is just a generic formula that everyone needs to know. So I'm looking for the length of segment FG, so let's plug it in, guys. We got the square root of 5 minus 1 squared, plus the quantity, we have our y2 here, so we get 5 minus 2 squared. Kind of. We didn't do all the work with it, but you know what I'm saying. We're doing it here. All right, guys, here's where I need you to remember to show work. And never get rid of the radical sign until the very end. So with this, I know I have my 4 squared. I have my 3 squared. That's what I get from making up an example off the top of my head, Michael. All right, right? What do we have? Simplified out, 16 plus 9. I get the square root of 25, guys. You all should know what the square root of 25 is. All right, so that's the length of segment FG. Now look at the problem. It says determine if the two segments are congruent. So we need to know if JK has the same length. So do I have to do this whole process again? Yeah, so let's do it again. Oh, I gave up, took a lot of room. I'm gonna have to write small for my next one. All right, so my distance formula again, writing smaller here, is gonna be x2 minus x1 squared plus the quantity y2 minus y1 squared. What are my ordered pair? What's K's ordered pair, my friends? What's the ordered pair for K? My coordinate. No one knows it?
Oh.
-1, -3. I was getting a little concerned all of a sudden. I had -1, -3. What's the one for J? -4, 0. Guys, which one do you want to be 0.1? Okay, does it matter? Here's the cool part. Does it really matter? If you want to be different than me, you could try it different. You'll come up with the same answer. So if you do this, I'm going to do -4, 0. I'm going to do x1, y1. A lot of you said K here, so x2, y2. I want to find the length of it, so I'm going to sit there and plug it in. x2, I have a -1 minus a -4. Notice when I plug stuff in, I use parentheses. Why? I don't lose track of my negative and positive signs that way. You guys do when you don't. So when I have y2 is a -3 minus y1, which is 0 squared. Guys, if I subtract a negative, it makes it what? All right, so it's a -1 plus 4, which gives me 3. So we got 3 squared here. I have another -3 squared. I get the square root of 9 plus 9, which is the square root of 18. I ran out of space. I'm a little mad at myself. Can anyone tell me what that simplifies down to? This is radicals from... Yep, 3 square root of 2. Some of you are like, I don't remember this. Even if you didn't remember this, what would you tell me about those two line segments? Are they congruent? Because did they have the same radical? No. So we can then say segment FJ is not congruent to segment JK. Now, number 6. We're going to skip it. But look what you're asked to do. It just says, use the distance formula to find the distance from D, 3, 4 to E, -2, -5. Is it any different than what we just did? No, we're just doing it for one line segment instead of what? 2, right? Now, some of you are like, I don't remember how to simplify radicals. I reteach that to you second semester, but if you ever want to come in after school, come talk to me. I'll show you in like 2 minutes. You'll catch on really fast because it's just a review. All right, let's do this last one together. I think, what time do I get out of here with you guys? Woo, we have time. Okay, this is good. You actually might have time. Maybe even go back to example 6. All right, this I think is in your actual directions on your calendar, not in your book. But you know how we could work backwards with midpoint and find the point that's missing, the endpoint that's missing? We can work backwards pretty much the same thing with distance formula, except for I can only find one of the missing parts of my coordinate with it. And so this again is just another work backwards problem, because I told you that there's distance here. I tell you that there's 2 points. I'm going to tell you right now, when you label these, the missing variable always needs to be your x2, y2. And then we're going to plug in our formula, and we're actually going to use lots of fun algebra skills in order to solve for it. I love this. It's so much fun. You know, it's something I expect an advanced kid to be able to do. So with this one, just like before, don't you think I'm going to have my distance formula? But notice, for ease of things, oops, I need to put a y there, not an x2. y2 minus y1 squared. I'm going to put my distance at the end. Does it matter which side you really put the d?
No.
As long as you have an equal sign, does it? It really doesn't. Remember, symmetry property of equality says you can switch sides. So with that now, I'm going to plug in what I have for my points. Just like we've done, everything so far hasn't changed. I'm going to plug it in. x2, though, is going to be x. x1 is 1 squared. y2 ends up being 8 minus 2 squared. And what does d become? 10. We're going to simplify for a little bit. So my quantity x minus 1 squared stays there. The radical does not go away. I get 8 minus 2, which is 6 squared, equals 10. I'm still going to keep simplifying. I'm probably showing almost an overkill of steps, but I want to make sure you guys follow along with me really well. Do I have to go ahead and square, because I'm just doing my order of operations, the 36? And the answer is, yeah, I can go ahead and do that. But now, the only thing else I could do is I could FOIL, go x minus 1 times x minus 1 and get that. But I'm going to tell you right now, don't do the work. What's one thing I probably could do right here? All right, Corbin, I've been ignoring you today. What do you got?
You should square both sides so then you get rid of the radical.
If I can take a square root sign and just get the square root sign by itself, then you can go ahead and square it to get rid of it, right? Because inverse operations. So I'm going to go ahead and square it. And so when I do that, I get the quantity x minus 1 squared plus 36 equals, what's 10 squared, guys? 100. What are you going to do next? Yep, you're going to subtract 36. And that's going to give you 64. Now, again, you could go ahead and FOIL out x minus 1 squared. But if I can do it quicker, I'm going to do it quicker. What can I do? Zach? Now I'm going back to square. Doesn't that mean we just got rid of the square root and now we're doing what again? Square root. This is why I love math sometimes. We get to do so much fun stuff. So now we're going to take the square root of both sides. But this is where my algebra students transition to geometry crashes and burns. Is that correct, what I wrote down? If you said yes, you're wrong. You have to have a plus and a minus. That's the only difference. Because a negative 8 times a negative 8, can that give me 64? So if I don't take that plus or minus, am I eliminating a possible solution? So I have to have that there. That's why I put it in red, so you guys could see that. So then we get the following. X minus 1 is equal to plus or minus 8. So you get x minus 1 is equal to a positive 8. Then I get x minus 1 is equal to a negative 8. Can I solve both of those equations now? X will equal 9, or x is going to equal what? Notice, with the midpoint, could I come up with an exact answer? With distance formula, can I come up with an exact answer? But I can narrow it down to how many? 2. I can narrow it down to 2. And this is, to me, the funnest thing, is being able to do algebra like this. But do you also see why I describe it as working backwards? Because I'm using the end result. I already know the distance, so how can I use that formula to get what I want before? Does that make some sense with you guys? Yes. Question, Peter.
Oh, I understand it.
Now you understand. You just had to think about.
How distance can be negative, but then
It's not distance is negative. All right, guys. Actually, this is a good question. Peter looked at it and he said, "Why can I have a negative answer here and be okay?" Distance is not negative, but can a coordinate for an endpoint be negative?
Yes.
So that's why we had to take into both considerations. Peter, I'm glad you brought that up because that's a good thing to know. Excellent job. All right.